Alright, welcome back to the stream. Looks like we're getting the bits flowing. As usual, we're going live on YouTube on the Scanlime-in-progress channel, and then over on twitch.tv/scanlime, and then getting the bits right from the source. You can do that at live.diode.zone/scanlime. Looks like those are all working out. Finally have that elusive chunk of hours where I can work on a single project without having to manage anything else. And it happens to be dark, which, as much as I like recording in the sunlight here is beautiful and calming and just nice all around. This is a light art project, so it does benefit from some darkness to exist in. So that'll be alright. So this might be a bit more of a nighttime stream for folks near me, but maybe some folks elsewhere in the world. You know, this is more like a morning stream or something. And there's the archives. And as usual, I'm also just recording a bunch of footage to put together into edited videos later. Although right now my priority isn't necessarily getting this edit out as much as it's getting the physical object out of my shop. So I've just got too much clutter right now, and this thing's been taking up space for about 3.5 years now. So it's time to do something else with it, and this stream and the previous one has been kind of my attempt to convert these atoms into bits and have them not take up so much space in my shop. So part of that is going to be just like going through what we've got and getting some more documentation of it, because I didn't really get much documentation of the finished thing. And then part of that is going to be figuring out what to do with its current form. You know, what to take apart, what to reuse, you know. Maybe somebody wants it in its current form, but I'm not that invested in trying to find it a home, because I don't really like it that much. So I'm maybe more interested in taking it apart and repurposing the components. That's the cat. Welcome back. I don't know if anybody's actually here because this is such a weird time, but here's Tuke. Anyway, my main goal for this stream is to take apart the crate, or at least most of the crate that this thing is in, because that's what's taking up a lot of space. But since it is nighttime and I have it running, we could get some video of it running. I also kind of wanted to go into the multi-channel audio thing, which was vastly over-engineered for what I actually ended up delivering, but that was really just due to my failure of scoping the project properly. So it's this interesting setup that I kind of wanted to build for a lot of reasons and ended up kind of trying to turn into a standalone project, which also failed for different reasons. But yeah, maybe it's interesting. It's this kind of weird approach of driving a bunch of D-Day converters in parallel over an FTDI FIFO chip and controlling a separate clock generator to manage the transfers between those. And so I never wrote like a real audio driver for that, but I do have some kind of weird C program, I think. I don't remember exactly how I cobbled that together, but I think it was just a weird special purpose C++ program or something. So yeah. Welcome back, anyone who's with us. Looks like there's a few of us here together enjoying this cat. Maybe the cat needs to be full screen. So the previous stream, I went into a lot of the just like the story behind this project, basically like what came before it, what I was trying to do, what the process was like, how I managed to fail at what I was trying to do. That was all like last stream. And I didn't have much video documentation from the actual build because that was from before I was doing any kind of streams, and I think it was after Coaster Melt, but before the sort of regular videos and definitely before the streams. So I wasn't really as used to getting video, so I had a lot of photos. A lot of them I hadn't even really categorized or put up anywhere because I just was so annoyed with the project I didn't want to look at any of the media for a long time. But at this point, I'm still annoyed with it. I'm still disappointed in the project and in myself. I still have all those bad feels, but I think it's more important to me to actually have the space free in my life and in my shop. So here we are. Anyway, you might have also noticed this cycling on and off, like of some fans in the background. That was another misfeature of this thing. The 5-volt power supplies have these annoyingly cycling fans. I forget how that happened. I think I had to compromise and choose fan or power supplies that weren't entirely fanless just because of the amount of space and the power that I had. But then I don't think that's actually true because I think I probably could have gotten away with, you know, less 5-volt power and less fan. And then of course I had no idea the fan would cycle or be so obnoxious until I was basically finished assembling the whole thing and there wasn't really any time to do anything about it. And I don't know, it wasn't too bad in the original gallery situation that it was in because there was a lot else going on. At the minimum, there's like air conditioning systems and stuff, and it's like high up and all that. But there were actually some kind of loud sound art installations in the gallery also, so it was not a big deal. But anywhere else, it's pretty annoying, especially if you're running it with the sound muted like it is right now, which isn't normal, but I think I was just kind of running it kind of ambiently here in the shop a little bit over the past 3.5 years, and at some point I'd edited the configuration files to turn the sound volume all the way down. Oh gosh, Tuco was giving me a hard time just a second ago because I think he's hassling me for his favorite cat food, which I give him a lot of, just like not quite as much as he likes. I was trying to give him this blend of something slightly different, you know, a couple of things he's had, one thing that's a little new to him, and trying to see if I can find something that is both like healthy and that he likes. But I haven't taken him to the vet since like last fall, so I figured it was time for a checkup and get him, you know, maybe get some advice about his like eating fussiness that he's been having for the last little while. He's been kind of a fussy eater, but it just seems like it's just getting like very slowly and steadily worse as he gets older, because he gets used to the flavors that he's found that are the tastiest, and then it's like hard to convince him to eat anything else, which I think is a pretty common problem with cats, but I just want to make sure to stay on top of that. And little guy stresses me out sometimes with his, you know, eating fussiness, but also with how he's always climbing stuff and finding things to chew on. So nice to celebrate the calm moments when we have those. Anyway, this is one view of the art thing. These wires actually would normally be under tension, at least some of them would be. But yeah, so like it's in a packing crate, which it's been in since the deinstall, which is not the most picturesque thing. It's really just designed to be sort of a floating, glowing orb in a black room. And then really everything above the orb is technological affordances that are necessary to make the orb work. But I tried to set a goal in this project of making like pretty much all the technology I could be as unobscured as possible, and just like have everything be visible, but also kind of have everything that can be multi-purpose kind of to an absurd degree. So pretty much everything is structural and electronic and visual in this project, which was one of the things that complicated it so much. So yeah, kind of the idea is that you would have this different view from very far away that would be more of this abstract kind of light mapped object. You know, from far away you would be more seeing the texture created by the shader that's running on this, really. You'd be seeing that light pattern. But then you get closer and then you see the glass, and then you can find ways to look through the glass here. And then there's this intricate structure inside with these kind of like weird alien pointy things with you know, curves of light flowing around them. And then in the center there's this kind of soccer ball polyhedron sort of shape that's actually made of sensor circuit boards, and then all the sensor circuit boards have this weird three-dimensional circuit routing on them. So I spent so much time on the very inside of this because I guess part of the artistic idea that I thought was cool at the time was that it would represent just all this intricacy that can go into, you know, something like this, you know, some kind of like technological organism or whatever. And you don't actually notice it unless you step in and look through the exterior. And I thought that was kind of cool. But I think it didn't really translate as well as I was hoping, and there's a lot of things that I would do differently if I had any time to prototype this, really. Part of why I feel so disappointed with this, really, is that I just tried to do way too many new things that I hadn't tried, and, you know, a lot of them I probably would have done differently if I had known how they would have gone. From fabrication techniques to, like, art concepts to scheduling to, you know, materials. There's a lot of things that I would do differently if I had had a chance to prototype this or do it again. But I don't know. It's a weird little project with this strange orby thing inside. And the thing that I'm most disappointed in is that, like, the thing that I cared the most about in this project was making it an interesting interactive feedback loop. And this thing is not interactive at all, because I just didn't have time to write that part of the software and didn't have time to tune the sensors to a useful degree. So this thing in the middle is just covered in sensors. It's IR emitters and IR receivers. And my hope with this was that even with all this junk in the way, I would be able to measure the difference as just like a body gets close to this thing. And I would be able to at least know, like, there's probably some degree of reflectivity at this kind of, you know, quadrant of the room, and use that information to create this effect where as you get closer to it, the light patterns would react to you. But there were just way too many things working against that design, from, you know, the optical properties of this whole thing to, you know, the sensors I used I don't think were quite as sensitive as I was expecting them to be. And I didn't really have time to do all the fancy closed-loop filtering stuff that I was planning on doing in the FPGA. So, yeah, there was just way too much reach for this project, and I needed to keep it simple if it was going to be, you know, not a huge burnout and a huge disappointment. So yeah, this thing kind of burned me out on making art for a long time. I mean, basically, I'm still burned out on making art, but I'm trying to get over it. Tuco really wants to play right now. So then inside there's that ball of sensors and all the LEDs. It's kind of hard to see what the actual structure of the LED stuff is, but there are sort of these struts that extend outward from the inner sphere, and they both support the whole thing, and they hold the LEDs and their visual elements. And the actual support, each of those struts has several wires tied around them. And then those wires go up here to all these effectively 3D printed leaf springs that distribute the load between all those wires to hold the heavy ball up from the triangle. So inside the triangle there's a plywood core that's really the core strength that it gets. And the plywood, I said at first in the last stream that the plywood was kind of a failing of that, like, artistic constraint that I set because you couldn't see it, but that was me misremembering how I built this. Actually, in the very center, the wood is exposed for exactly that reason. So the very center of this structure, there's a circle of wood that's exposed, but that's actually the wood that goes throughout pretty much this whole structure. But the exterior face of it is copper clad on the bottom, and then aluminum on the edges, and then it's got a bunch of 3D printed parts internally. Hey, Tuk Tuk. Gosh, do we need a cat break? Chat's been pretty quiet. Looks like we've got a little bit of, got a few people in YouTube at least. Hello. Tuk Tuk. Oh, he just really wants to play now. I thought he was going to sit, but he sees me paying attention to him, and now he just wants me to throw the bolt. Anyway. I don't feel like chasing him around with the camera right now, so let's just keep our attention over here. Maybe I can at least get the robot somewhere where it can see Tuco as he comes back. Leg cam. Yeah. Well, I should turn on the sound because that's another interesting aspect of this. And you know, I don't want to do too much sound when it gets really late, but it's still not that late here. So the top structure, most of what you're seeing there is actually speaker cabinets. I wanted this thing to have a decent low range. I didn't want the little speaker drivers to just be really tinny. So I tried to make this an array of speakers with enough cabinet space to actually have a low end, and I think I achieved that at least. It sounds all right. And so the stuff at the top is actually all audio related. Actually, not that thing at the front. What is that thing at the front? Oh, you know, I think that thing at the front is actually a DC-DC converter that was supposed to be for stepping the 24 volts down to 12 volts. Because there's a few different voltages in here. I've got 5 volts for the LEDs and the Raspberry Pi that runs this whole thing. And there's a USB hub. So the USB hub powers the Raspberry Pi, and then the USB hub is powered by the same 5 volt supply that powers all the LEDs. Then there's a 24 volt supply for the audio. The Class D amplifiers seem to like a little bit of higher voltage, you know, because then you can get more power out of the speakers. But yeah, I originally wanted to step the 24 volts down to 12 volts and then use that to run the IR emitters in that center ball. They're like security camera style IR emitters, like CCTV little cans. They're intended to run off of 12 volts. What was the deal with that? I think they originally had a separate circuit board that acted as like a brightness control or something, but I forget whether they originally were designed to be used with the DC converter or not. I think they might have originally been designed for a DC-to-DC converter, but I modded them for use with like traditional like series ballast resistors because I didn't want the optical like, modulation noise from a DC-DC converter. So the idea here is that I have a really stable power supply for the IR emitters that could be generated by a DC converter or whatever, but I can filter it really well. And then that's modulated by a bunch of MOSFETs that are local to each IR emitter, and then each emitter also has its own like ballast resistor in series with that. So that's how the transmitter in the middle works. I think the problem I was having was that it ran too hot off of 12 volts like I was planning. And I was worried about cooling with it being in the center of this orb that's also full of LEDs that just doesn't have a whole lot of cooling total. So I decided to run it off of slightly lower voltage. I think that also improved my signal to noise for some of the testing I was doing. I don't know if I would have kept that just for that reason, but yeah, I ended up running it off of a slightly lower voltage, and I think we'll look at the top and you'll see like a little like wall power supply and like a cutoff end of an extension cord, and that's actually like a 9.5 volt power supply or something that I'm using to run the LEDs. Oh yeah, the sound cycling is not great. Let's SSH in. So yeah, I actually already had this set up to be on my network because I was just running this a little bit in the last 3.5 years that I had it here. So it's on a Raspberry Pi. The Raspberry Pi is fairly heavily loaded. It's mostly running this. You might, I don't know if anybody knows the names of these binaries, but this is actually the name of the binary that usually runs the software for a totally different project of mine, and I basically hacked up the source code for an old art installation to make this one because I didn't have time to make the thing that I actually wanted to make. But it is at least in its own repository. Hey, Tuk Tuk. It stresses me out when he goes back in the corner, because I think I've covered all the cables, but he's really good at finding stuff I missed, and he's probably just hunting a bug, but I never know. Tuco, what are you doing? I also don't want to squirt him with water when he's right next to all the power cables. Tuco! Gosh. Tuco, what are you doing? He decides stressing me out. Tuco is so bad for an anxious cat mom like me. Tuco, 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 Tuco. Tuk, tuk, tuk. He likes it when I'm paying attention. Making sure that stool is his. Yeah, okay, he just really wants to play right now. My cat is addicted to fetching these bolts. He just will not give it up. It's like not a bad hobby though. It keeps him entertained. There's a lot of stuff where I think he can do it on his own. He just likes to have a partner. Like, I've seen him play Bolt on his own, just like batting it around and then chasing it. He also has an exercise wheel, and he runs on it on his own sometimes, but a lot of the time he'll sit in the wheel and meow at me because he wants like an exercise partner. Oh, you couldn't quite see him that time. Maybe let's get a slightly different camera angle. Giving myself some extra obstacles for the camera today. Got a bunch of light stands set up to try to hang this art off of them, which is, like, I don't have any like rigging points in the ceiling here, which would be great for this. Like, I've wanted ceiling rigging points in this space for a long time, and I just haven't actually done the work to do that. So like, I need to do more research on that, but it would require all sorts of, I mean, it would require the right kind of clamps, it would require knowledge about how the roof works, it would require a way to get actually up there, which I have a ladder, I just hate using it at that extension because it's so tall and I don't like heights. And yeah, but anyway, it would be great to have a hard point at the very top of this area just to like hoist hanging art weirdo objects like this. If I had something like that, I could make more like chandelier kind of things. But as it is, I was here in my shop building a thing for that kind of an environment, because they have plenty of hanging points at the museum that this was supposed to be for. But I didn't actually have that. So my solution was to take 3 of these mobile light stands that I have, and I think the way I was doing it before was I just hung, like I ran a separate rope from each light stand to one of the hang points on here. I decided to do it slightly differently this time, where I have the 3 light stands all connected to a central pole, and then I have like a pulley on that pole, which seems a little better than how I was doing it last time. It's also a little more similar to how it was actually rigged at the gallery. Oh yeah, Tuco makes great sounds when we're playing fetch together. Good evening, everyone. Oh, Tuk Tuk. Oh, is he gonna chill right here? Whoa. Oh gosh. Tuco took an interest in the robot just then. Oh shit. And I zoomed it up to try to get it away from Tuco, and it's stuck on the light stand. Oh gosh, Tuco. Oh man, the control algorithm for this robot is really simple, but mostly it just involves trying to use feedback based on the rope tension. And that's actually been pretty cool. Like, I haven't seen any Winchy robots like this that use tension feedback like this, and it's been pretty cool that that part of the experiment seems to be working. Like, it's not perfect. Like, the tension does have to vary for this to work, and so I don't get the kind of perfect winch winding that I would get, but like, it seems like it might be worth actually doing a WinchBot 2.0 at some time, because I've learned a lot since designing this system, and I can imagine some much better ways for the winches to work. But then again, you know, it's not like I need to make a product for this. It's not like I'm getting into the theatrical winch business or anything. Certainly not by myself. And yeah, so I don't know. I don't currently need a new revision for this particular use, so it would be a lot of work to go through for something I don't actually need, but, you know, add that to the heap of potential projects. Anyway, what do we have here? This is also going over Wi-Fi, so the connection might be a little bit hit and miss, I guess. I mean, I could plug in Ethernet. It just seemed like a hanging art thing. You wouldn't want to have to run any more wires to it than absolutely necessary, so I usually do use this over Wi-Fi. Oh, gosh. Should we have a local checkout of this for just browsing around? Recording, right? Yes. Oh no! Jarrett says their friend's cat they watched would refuse to eat unless you were standing in the kitchen with him. Yeah, sometimes that works with Tuco. Like if he's being stubborn about food, sometimes you can just like stand next to the food that he hasn't finished yet and he'll get the hint. Not right now. Always with the software updates. Anyway, I think it would be cool to go into this a little bit. I think the first thing I was going to do is look at the configuration file. 'Cause that's actually the current diff in this tree. This is in decibels, I think. This takes a bit of a page out of what I was doing as far as coding style from High Quality Zen, I think, which is this old renderer that I wrote. And for that, I was doing this thing where I was basically using JSON as my internal data structure for everything, but I was using a JSON library that gave me really fast read-only access to that with a pretty nice minimal data structure. And then I was doing most of the string lookups ahead of time and then just storing references to this immutable JSON structure. So it was this way of using JSON pretty much throughout the whole application, even in performance critical parts of it, but without having to do a bunch of like tree traversals and string compares and stuff all over the place. So I liked that. I don't know if anybody else likes that. Most people don't really even seem to like programming unless it involves like Rust or JavaScript, so a lot of this code is probably just going to be gross to most of you. But yeah, let's see. Let's just try a get check out of that file. And I think this is normally started by supervisor D. I think if I just kill this process, it'll restart. Actually, who owns it? I think my user owns it. Ah, it just restarted. This is how it was running in the installation. The sound, like everything else, was not interactive. It was just this loop. Oh, I did actually add some randomization to the mixer levels. So I was intending this to be kind of this like soundscape with a bunch of different things that you would move through and like some kind of spatial audio or whatever. But of course I didn't have time to implement any of that. And so my compromise solution was to write my own just low-level mixer for this weird multi-channel sound system. And then I don't remember how much of this was per channel or how much of it was global, but it just had some like slowly varying Perlin noise to mix some tracks between different mixer levels. And I think we'll take a look at that and try to see how that was actually working, because I was in such a hurry when I wrote this. You know, I left really not enough time for the software, like not even close. Oh gosh, Ed wants to know about the Tuco flare swinging. Yeah, some of it is caused by the tension feedback loop. That is certainly a cause of some of the oscillation for sure. Not all of the oscillation. Like if you're here in this room looking at the thing moving around, or if I have like a wide angle camera set up on one of these streams, you can see the traveling waves as one of the winches starts and stops because of the tension algorithm. There are a lot of aspects to that though, like the tension algorithm itself could use a lot of improvement. I want it to include like some derivatives and not just like first order stuff that it's, or you know, like additional derivatives. I think right now it just uses the actual tension, whereas I think I want to look at like the rate of change of tension. Then, yeah, I think the other thing is just that the lower level PID loop that's under that kind of oscillates a little bit when you try and start and stop it that suddenly, because that bypasses some of the normal velocity limiting. So like, yes, that's a huge rabbit hole that I could go down, but yeah, I'm not going to make this stream about Tuco Flyer. Let's see, where were we? I think I was just going to adjust the camera. The bass on this is pretty nice, though. I'm happy with how that turned out. If I can move the microphone closer. I guess that was one thing I was trying to do with the sound system, was I wanted it to create this sound that doesn't seem like it should be able to come from this object. But then, you know, it's just a weird thing. It's a weird object. The off-road shaky cam here. Photograph from that side. It's not ergonomic. So I think I'm learning that trying to film this thing with a tripod is basically impossible. I just have to go handheld. So I'm lucky this camera has image stabilization, but it'd be great if I could use my gimbal. I just usually use the gimbal with a mirrorless, and I don't have a mirrorless camera with HDMI out, unfortunately. So I can film it, but I can't show it to you live. So I might just do that later. But I think I'm going to do some more of that handheld, at least after I get the crate off, because I think that'll be easier and it'll look nicer. Oh, you can see the new color keying fail. So I had a pretty reliable way of doing the transparency on this camera before, and I think the new version of OBS, I had to change it around a lot, and it's not working quite as well. It's funny, actually, the change they made in OBS removed, no, that's what it was. They had it match by, they take the chroma key kind of literally, and they're actually matching by color and not by like RGB value. So they're matching by something like hue and lightness or something. I think maybe just hue, because if I try to chroma key to black, then it catches like anything grayscale. So I ended up using the lookup table remapping filter to convert like the black background that I had into some other random color, and then to also convert that other random color into something very close by, and then I took that other random color and used it as a chroma key. So, oh, I should point the microphone at the object. To better hear the fan noise. Alright, well, I think at this point I just take off my sweater and put on my safety glasses and start taking apart this crate. So right now the sphere itself is resting on this little support at the bottom. There's this little 3D printed cup, basically. But just barely, it's very small. It just sits there, and then there's some bubble wrap on the sides to keep it from rolling around and hitting the sides. But the top, like all the electronics and everything else, there's really no way to just take it off. There's no way to sit it down. Like, you can't like move it around. It's a very awkward object. It's just designed to be almost as awkward as possible. And so the way to do this is I have it under some tension already, but the rope isn't really holding it up. I have it rigged already. I need to take off those C-clamps and then make sure that I can support that top assembly at least on the ropes. And then I can unscrew that diagonal piece of wood, and then it's no longer being supported by the crate, and I can just take off the other pieces of wood. So I'm just gonna try to do that and mostly not talk about it. Oh yeah, I also have this plugged into a power meter, and it says it's been at around 90 watts. Yeah, I'm pretty happy with the music. I just wish that I would have been able to actually do some of that interactive audio that I was planning on. C-clamp off. Top section is hanging now. It's funny, I actually borrowed those C-clamps from a neighbor, those specific ones, and then I realized that I wouldn't be able to give them back for a really long time, so I had to buy them some new C-clamps. This just has one screw on each side. Gosh, this also has written instructions, which are pretty useful. I don't even think, I mean, this is definitely not my handwriting. Like, some of the handwriting is mine, but some of the written instructions were written by the museum staff as they were figuring out how to take this apart, I think. And it's not, like, necessarily how I designed it to come apart, but I guess that's what they thought was easiest. Yeah, there's a piece over here that says take off first. I don't understand why, but maybe whoever wrote that had a reason. I think these boards on the side were kind of a late addition too, because they, I think they were just to keep this thing a little safer in the van or in the truck or whatever. I took it to the gallery myself in a van, but then they shipped it back, I think, on a truck. Alright, let's take the sides off then. I think there's also some tape to cut. I know I'm wandering around away from the microphone here, but I think it's probably better to use the stationary mic than the wireless for this, just because then I can keep this pointed at the orb. Gosh, I can finally take off this bubble wrap too. This has been tempting Tuco for years now. I'm not getting that on camera, but maybe I don't care. Side ones on camera, maybe. This isn't going to fit in my little trash can that I usually keep right here. Oh yeah, it is pretty calming. Oh, sorry about the flickering. I'm still debugging some video issues here. I don't think that'll show up in the recording. That's just in the viewfinder. Yeah, years. I think I made this like 3.5, almost 4 years ago. Yeah, you do kind of keep hearing different parts of the track too because of that mixing randomization. Gosh, I should try to get the microphone in closer because it does actually sound kind of cool. I really didn't design this microphone to be easy to move, but let me see if I can anyway. Hear a lot of echo because this is a concrete room. showed this video. I don't know if anybody can hear me when I'm at the desk. Check that. Gosh, yeah, I'm not really audible when I'm behind the microphone, huh? Stripped already. Really? I haven't taken this apart or put it together since it came back from the gallery. Like, I think these are gallery strip screws. Yeah, they came that way. I mean, I'm sure they were just in a hurry to get it back together. Says take off first is that the way that they would do this. Yeah, that's right. Yeah, I was there. This was like a team effort. This was like me bringing this unwieldy object into the gallery and getting their help installing it. And so, like, I think we took one side off and then got it ready to slide out, and then took the load off the top like I've already done, and then just slided it out sideways. I think we actually put the crate under where it was mounting and then lifted and then slid the crate out from under it. access to one side. You can kind of see how much the whole thing is leaning right now. Complaining about the video going black. I know about it. It's not helpful. I'm talking about the recording that I'm making with the camera, not what you're watching right now. The thing that I'm recording is the thing that I care about not having black frames in. Sorry. These are probably really bad screws that strip easily. Oh, yeah. have to remind people that the goal here is not necessarily for the stream to be the prettiest thing, but to get good footage for later. missing a screw. pressure without just pushing this thing across the floor. That's weird. I just hit it with the drill accidentally, just pretty gently, and the audio stopped. I wonder if that was the FTDI device dropping off the bus or something. Let's see if it was a software problem. Otherwise, we would have some hardware debugging. The lights are still going, of course. Oh yeah. I think I just introduced a glitch in the USB connector between the FTDI device and the Raspberry, or one of the USB connectors in the drill. So I guess it's a little bit vibration sensitive. All these screws at all these weird angles holding these boards together. This crate was really a team effort. I think there were 3 of us who ended up building this crate, or maybe 4 of us. It was like me and a friend who was helping me with the, some of the last minute stuff, like building the crate. And then I think the crate was then reinforced by some of the gallery folks when they were putting it back together by adding those extra pieces around the side. And some more of the screws. I don't know where all these screws are not mine. Splintery. That would be surprising, but it was still surprising. Okay, take that piece of wood with me. Thanks. runs on WAV files in JSON and C++ code. So much of that I've been putting off until I upgrade the camera, which I've also been putting off because it doesn't seem like an urgent use of money. This would split because I don't think we pre-drilled it everywhere. Total rush job. Oh gosh. Corners are nailed together with angle ties. That's complicated. Gosh, maybe the thing to do is to actually raise this a little bit and then get it completely out of the crate and then disassemble the crate. I don't actually know how hard it is to raise right now using this pulley I've got set up. Maybe that's the next thing to try. Lifted the metal thing up a little more. The actual ball is still sitting on the ground. Pretty sure. Yeah, it's still sitting there. Well, maybe it's good to keep this part assembled until we know that we can lift it slightly more reliably. This might be a good place to leave this until I've got maybe some daylight. This whole thing is just so unwieldy. Like, everything about it is annoyingly hard. Like, on purpose. Like, I didn't want it to be easy. I figured that if it was hard, then it would work out. Not even close. Some tape on the top for alignment. Just left some sticky. Right now. Maybe I add a second pulley to make this a little easier to lift, actually. Alright, I'm going to do something sensible, and maybe while we have some darkness, I'll focus on taking some more video, and then I can make this more of a mechanical problem tomorrow when I have a little bit more daylight. Maybe that's the way to do this. I don't know. It doesn't hurt to get some more video of this right now anyway. Let's try getting in a little closer. This is just kind of an awkward angle, because this was intended to be, I mean, in the gallery this is sort of eye level, and so you're looking up at the triangle part of it actually. different issues that might all be causing that black flash that you're seeing. There's a capture card issue, and then there's maybe also a problem with the cable. Safety glasses are fogging up. I think that's maybe about all I've got in me for this stream. It's pretty amazing how directional this microphone is. It didn't really pick me up at all from behind. Anyway, yeah, I think that's about where I'll wrap it up. It's getting a little late for power tools and audio here, and looks like Tuco wants to play. And I need to rethink my securement strategy for lifting this thing up and then securing the rope a little bit so that I can try to get it a little bit higher up. But yeah, we might be able to go into the software side just a little bit if anyone's still here. And gosh, maybe I can replace this HDMI cable before the next stream, because that might be at least part of the problem with this camera. Although I still suspect it might be related to the capture card, because I started having problems with this signal and a totally different signal at the same time, but I'm still trying to debug all that. Oh, let me see if I can get this mic back into the usual place. Oh, I thought I could do that. I thought I could do that without making a huge noise, but then I did. I think that's how I had it attached before. Oh, Tuco, what are you doing way back there? What are you doing? Tuco, what are you doing back there? Makes me so nervous. He likes climbing around on all the electrical wiring. Yeah, the haunting music. Anyway, yeah, sorry for all the random video and audio quality issues there, but I'm just trying to get some footage and I'll edit together the good stuff later. Left keyboard focus on Ableton. How to go? Yeah, so how did any of that work? So it started out as this Ableton project, which I showed a little of on the last stream. And then I rendered the tracks into these WAV files. I think that was all set up by this config file. Tuco, what do you got? A bolt? Yeah. So this config file controls all aspects of it. So there's like a subsection for the sound mixer. There's master volume level, and then randomized level and on or off for all the tracks, basically. And I think it re-randomizes the tracks at the beginning of each loop, if I remember right. And all of this is config for the visuals. These are all just different patterns and parameters for each pattern. you know, anybody who's tweaked kind of like RD software, like you know that a lot of it is the process of tweaking parameters. And so I never had like a good interactive parameter GUI for a lot of this, but I could at least edit a config file and then try it, which is better than having to recompile it. Oh yeah, and then layouts. So these are more JSON data files that describe where all the LEDs are. So I had a couple of just kind of generic layouts. But then this is the one. This is the one that was the output of the photographic mapping process that I showed some excerpts from in the last stream. So this one is the calculated position of each LED from the photographic maps on a 2D plane in this case. And then this is just some additional information about each of the photos that it took, which is a little bit more verbose. I didn't store all these files in GitHub, but I think I have them elsewhere still. Is the whole mixer in this header file? This is the whole thing, isn't it? For the DAC, at least. Not the mixer, but... Tuco really wants my attention right now. Yeah, so we had this multi-DAC. Let's get a slightly better view here. Oh, I hear you, Tuco. Wow. Oh yeah, that was a good question. Laura was wondering what the audio volume was like when it was actually installed. The goal was to fill the space. I think the main problem with it was that the space was kind of crowded and there's just a lot going on. So I didn't have like an entire gallery to myself or anything. It was like one section of kind of a crowded gallery. It was basically like a little room, but it was open on the top, so it wasn't really like acoustically isolated. So actually, like a lot of the noise was residual noise from the installation with all the like clacking speakers. Like that one was pretty loud, and that was actually in like a sound insulated room, but it was still leaking sound everywhere else. But it was just like that, plus just like all the people milling about and everything. So I think the way it actually felt, it was like maybe a little bit on the quiet side. But like I could have been tweaking it. Like I don't think I was maxing out any of the amplifiers. I think it was just that I set it kind of conservatively, but you know, because I didn't want it to be annoying. But so it was like not just like boomingly loud or anything. But I think this volume level that you're hearing is probably what I was using in installation, because I suspect I just checked that code into Git and then didn't change it. But I know it's like hard to get a sense over all the microphone and speaker things that are in between you and this particular room. Yeah, this code was all incredibly simple, at least the audio stuff that I wrote. The LED art code is based on a lot of stuff that I had done in the past. So if you look at, for example, this is one of the scenes in the LED animation. And this is, I think you can find this in the Fade Candy repo. Maybe not. Actually, I think this is in the Ecstatic Epiphany repo. That's where I copied this from. So it's like stuff that I wrote earlier for a different art installation that I reused for this one. And so it's written kind of like a shader. Like it loads parameters, and then every time it runs a calculation step. Actually, some of the particle, or some of the effects were like just basically shaders. Some of them were these particle effects, which have this particle system that they update on every time step, and then that particle system is rendered to each LED by sampling like a summed set of like Gaussian points. So that's actually code that's from the Fade Candy standard library, which I wrote intending to use it for arty stuff like this, but it's also like part of the Fade Candy example code. So yeah, the LED stuff and the sound stuff are just kind of mixed in here. This is another. This one is basically also from Fade Candy examples that I modified for this. This one is not a particle system. This one's more like a shader based on Perlin noise. So it has this shader function that takes a pixel info and outputs an RGB. But yeah, most of these were particle effects. I liked the particle effects. It just seemed like a nice way of thinking about LED art. So yeah, this is all like fairly straightforward C++ code. And then some of this I think you'll find from, oh yeah, the narrator. Where did this come from? This uses the mixer class from, again, the Fade Candy library, but then it changes, get these crossfades. Like, I think narrator is a subclass of the, no, it has an effect runner, okay. But then it has a mixer somewhere, maybe? I forget how I put together a lot of this. It's all based on that C++ library that I wrote for Fade Candy, though. But yeah, the multi-DAC. So this is a weird multi-channel DAC that uses the FTDI FT2232H, which is a dual-channel high-speed USB FIFO chip. So you can send data at 480 megabits, or you know, with some asterisks. It depends on like how your code is written. It also depends on your clock source and like what modes you're communicating in. But it's a high bandwidth dual FIFO that you can communicate with over USB. It's not a microcontroller, it's just hardware, so you don't need to write firmware for it, which is kind of convenient. And then this libmpsse is a library that knows how to speak. It's, what does that stand for, MPSSE? It's like multi-protocol synchronous serial engine, I think. It's a pretty flexible sort of UART flavored thing, like a serial engine, but you can configure it for a lot of different protocols, including, I think, I2C and SPI and JTAG and some whatever. So I think here I'm using it to speak I2C to configure the clock chip that I'm using. And then I send the data, the audio data, already in I2S format to the FTDI FIFO. So now I've got I2S data at the proper clock rate that I can just send to a bunch of D to A converters in parallel. So that's how this works. So as far as public functions, you have start, and then it'll just start streaming audio to this thing in the background on a background thread, I think. But then it calls this callback function to give it a new frame of audio. So a frame is just one sample for each channel. Is that right? I guess I didn't batch anything more than that. So there's a lot of calls of this callback, but I don't think function call overhead was really a big deal for this. Some audio library, I mean, most audio libraries will batch together audio, but that's because function call overhead is more significant, I think. Is that right? Oh, no, I'm lying. This does batch. That's what numFrames is. So a single frame is, I guess you would think of it as like a sample. I guess some audio libraries do use the same terminology, like an audio frame. So this would be like one sample for each channel, one frame, and then a buffer would be a collection of frames. So the num frames is like how many frames are in a buffer. And then you get a call once per buffer. What was the actual buffer size? That was the buffer size, audio frames per buffer. And then the num buffers, I think, had to do with keeping several transactions like loaded into the USB host controller simultaneously to avoid latency between scheduling new transactions. Tuko, what are you doing, honey? I know, what are you chewing on? What are you chewing on, honey? I don't know what he's doing, but it's not good. He's probably chewing on Ethernet cables. Yeah, I guess there's a question in Twitch chat about this. Why did I send just one sample at a time and not say 16 samples? Well, it turns out I did send like 64 samples per buffer and then 16 buffers, so there was more than that. But like, it's a trade-off between a lot of things. It's like the overhead and all the function calls and like the whole like, basically like all of the abstraction penalties that you're paying, all of the setup that you're doing, you know, everything that you can kind of amortize over several samples by grouping the samples together. So that's what that 64 is, but then the 16 is like one level above that, which is the number of those buffers that are in flight at once. So yeah, but I mean, neither approach is like intrinsically bad. They're just different trade-offs between latency and different kinds of efficiency. And this is, I guess, what I tuned this one to. I suspect a lot of different parameters would have worked fine. I think this was just probably, I forget whether I profiled this or whether I just picked something that seemed good to me. Like num buffers, you'd want it to be at least like 2 or 3, but you could probably go a lot lower than that and decrease latency. I think latency still would have been pretty low with these settings. I love it when people in chat just like give me all these unnecessary details that happen to be wrong. It's like, oh, I think that's a Lumix camera. No, no, it's a Canon, but thanks for playing. Anyway, I was trying to go through the API for this. So yeah, you just start it, it starts a background thread, gives you a callback every so often. And then internally, it's got to configure the clock generator, and then it's got to pack stuff into USB buffers and send them to libUSB. I think I was using libUSB here. Oh, I was using libftdi, which is slightly higher level than libUSB, but it's based on libUSB. So yeah, that's going through libftdi to open it. So this is an MPSSC device. This is actually setting up as an I2C master at 400 kilohertz. And then just right here, we're pulling in the register map for the clock generator and setting up the clock generator. I guess there isn't that much we need to do, but oh wait, yeah, this reg store list. Did I define that separately? Tuco, what are you doing? Tuco. Gosh, cat is really difficult. Oh, register map. That's right. This is actually produced by this like Windows design tool that will set up all the settings for your clock generator. You certainly don't have to do this. It's documented. This was just kind of convenient at the time, and so I used it. Yeah, you go through the tool and set it up. But anyway, this gives you the settings. What was I using this for? I had a schematic for this actually somewhere in the repo. Maybe that would be good to look at, because I was using the 2 different outputs. So it's a dual output clock generator, and I think I was using one output to clock the FTDI and one output to clock the I2S devices. And I think I was adjusting the polarity or the phase or something. Tuco, what are you doing? I actually want to know what he's doing so I can protect whatever wire he's trying to get to. All the power wires are protected, but there's some Ethernet cables back there. But maybe he's not actually biting the cables. Maybe he just likes the confined space, because, you know, who wouldn't? Why are you pasting my own code back to me in chat? I don't understand chat most of the time. Tuco, what are you doing? just likes that spot. Can we get the camera on him at least? Oh. Where did I put that? Oh, where are you now? I am way too tired to be tracking Tuco right now. Whatever, I'll leave it here and maybe the computer will find him. Alright, maybe people just like pasting code into chat. Some people juggle geese. Anyway, so we're configuring the multi-DAC. I was gonna get up a screenshot, or a schematic, wasn't I? Tuco, what are you doing? What the hell is he biting? Just really hard to get back there and mess with stuff because it's just behind all this furniture, and it's like I need to get back there and see what he's biting. I can't do that because he only does it when I'm distracted, and this cat drives me crazy like 80% of the time. PCB. Oh God, what was going on in here? These are all the PCBs on the bottom of the triangle. These are all the PCBs on the outside of the sensor sphere. Okay, internal. I guess by internal, I didn't mean internal to the sphere, but internal to the triangular area. Things that weren't necessarily designed to be as visible. Tuco, what are you doing down there? I'm gonna spray you again. He was standing far enough away from the cabling that I could spray him without spraying the cabling. He doesn't seem to mind getting sprayed though, so I don't really know how to deter him. Well, yeah, obviously the thing I'm worried about is that Tuco is back there eating cables, but I can't actually tell what he's doing, because every time I try to, like, every time I see him out of the corner of my eye and I look and see what he's doing, he just stands perfectly still, like he's not doing anything bad, but, like, he's making noise and going back there, and I think he might be trying to bite the cables. He is just really, really good at getting into stuff. And he seems to take a special liking to things when I'm actually, like, busy here trying to get work done. Like I could be goofing off elsewhere in the shop, you know, and he would just be lounging around, he would be near me, whatever. And then I come down here and he's just immediately in my face. It's really frustrating. Anyway, I think I did these in Eagle. I don't think I have Eagle installed. That's Eagle, right? Yeah. Hugo, what are you doing? Gosh, now he's probably like biting my friend's cables because he's not as diligent about covering stuff sometimes. Hugo, what are you doing? Hugo, what are you doing? Hugo, what are you doing? Oh my god, that cat drives me crazy. And like anytime he's biting my cables, people are just like, oh, why don't you just cover more of your cables? And anytime they're biting my friend's cables, it's just like, I'm just really frustrated by everything involving keeping an eye on him constantly. Like, it stresses me out to not know where he is, and it stresses me out to know where he is. Am I gonna have to install Eagle just to see these schematics? Oh. Huh. Wait, was somebody really making an Eagle viewer that was also proprietary? I guess this is just a phone app. I don't know if I want to install Eagle just to see these. Ugh. I really don't like Eagle. Oh wait, does KiCad know how to import Eagle files? Oh. Oh yeah, let's try that. Oh. That's interesting. I have this habit of pressing tilde to go to my home directory in these file dialogues, and I remember being frustrated recently at that not working, but I don't know what's different between that setup and now, because it's working now. Weird. Project files, though. Huh. I guess it actually means board and schematic files. I don't think this is multi-select. Maybe we just want the schematic. Oh. I don't think that worked. Tuco, what are you doing? I think he's biting this USB 3 cable that I've got like 95% covered, and he's just biting the areas that I can't cover easily. But now he's just sitting on the floor like a cute little potato. Do you want pets, Tuco? I'm not really allowed to be there. If I pet you, maybe you'll relax and show me what you're interested in chewing on. Is it just me, or is this light flickering? Maybe it's just me. What is he doing? What are you doing? He really just wants attention right now. Honey boy. I know. Oh, dude. Oh, gosh. Looks like there isn't an electronics package that's nice to work with from Twitch chat. I mean, depends on what you mean by nice, really. I usually like KiCad. I mean, I wouldn't necessarily judge KiCad by its ability to import Eagle files. That seems to be pretty new. Yeah, generally I like KiCad a lot. I mean, the like poshest experience I've had with an EDA platform has been like Protel, but you know, that's like neither accessible for people nor reasonably priced nor open in any way. Like, it's just fancy. I like KiCad though. Like, KiCad seems like a good balance of everything, and it's improving at a good rate. And I've had a lot of fun using it to design lots of things, which is the reason I don't have Eagle installed right now. Tuk, what do you want? Meow. Tiger. I'm gonna have to install Eagle. Can I do that while holding the cat? We could try the importer again. It just doesn't seem to really be working. Fuzzy ears. Alright. Eagle CAD. Do I have to download it from Autodesk? I might have old versions of it somewhere, but whatever. Eagle has improved, at least, since Autodesk started inhabiting its body. Oh god. Standard, premium, and free. Uh-huh. What even is that? Like, that looks like a board that's part of the way milled. Like, they milled it using a large tool and they've still got to go in with the small tool. Blah, blah, blah. Blah, blah, blah. Blah, blah. Blah, blah. It says maybe I have to update the Eagle files before they'll import. I don't know, do I? All I know is that I tried importing them and it crashed, and then I tried opening the project file that resulted and it did not have schematics. We could try it again. I mean, I was in that process here. Tuco. No, don't go back there. Don't go back there, honey. Actually, I'll give Tuco a challenge. Oh my gosh. Yeah, the crash is reproducible. Maybe it was trying to throw an error, and then the error path is buggy. What is Tuco doing? I left my toolbox partially open, and he's trying to get it open the rest of the way. Oh. I really don't want to install Eagle, but whatever. Oh yeah. I remember taking this long the first time I opened it. I hear you, Tuco. Tuco. Tugo's being really picky about food right now. He had this food from earlier that he was not finishing, and he's just looking for something else. I relented and gave him a little bit of the stuff I know he likes. What version of KiCad? I don't know. Pretty recent. Let's find out. 5.0.1. We could try updating KiCad before installing Eagle. It really stresses me out to share the space and not have like all the cables covered. I need to deal with that. Like, sharing the space with cats and with humans is both of those are stressful in different ways. Oh, what was it doing? Oh, is that still downloading? It's an exciting part of the stream. Oh gosh, I'm looking forward to getting a snack after this. It stresses me out so much when Tuco just gets into my stuff. I don't know how to keep ahead of his curiosity. This doesn't seem to apply to upgrading from 5 to 5.1. Switcher is so slow. So we do this also. How generous of them. Metrics means and software means. Oh, notification means. Yeah. I think KiCad's done copying. Oh, that mostly worked. Cool. That's the right schematic. It's pretty boring, but well, that's cool. Guess I've got Eagle in case I need it, but hopefully I don't. So I think what I did here is, I think I labeled everything according to the FTDI board's signals for the most part. I don't know why I had both of those connected to SDA. This is not a very good schematic, actually. I think this was just the minimal schematic I needed to make in order to make the PC board. If I were doing this to be more legible, I would definitely want better symbols for all of these things. But anyway, these five connectors are all going to these identical D to A converter boards. I forget which D to A converter it was. It was just something I could find cheaply that supported I2S. And so they share most of these pins. We got 5-volt power, ground. I think AD7 is the left-right clock in this case, and then 4, 3, 2, 1, 0 are the data pins. And so I think 5 and 6 could be data for some additional D-to-A modules, but I didn't include those. So then this has the parallel 8-bit data on one port and the I2C data on the other port. The I2C data also goes to the clock generator over here. And so this answers the question of what the two clocks are. So this has I2C for control, power input, and then it has two outputs. So the oscillator here, I'm generating a B clock and a read clock. I think B clock is the byte or bit clock for the I2S ports, and then read clock is for the FIFO. So I think these are just alternating. Like I think read clock has an edge, and then B clock has an edge, and so on. So they're at different phases or different polarities, but the actual clock source is the same. And that's all there is to it, schematic-wise. This is the little board, pretty easy to mill, 2 layers. Vias I could make with little wires, I think. What's that about? I don't know why that was an air wire. Maybe that was a bodge, I forget. Anyway, can I open the other one now? There's one more board in here I wanted to look at. So the PCB triangle and PCB core, those were all done like in non-electronic CAD software. So they don't have Eagle files, they just have like SVGs. But I think everything in internal was done with Eagle. So I had multi-DAC, which we were just looking at, and then, oh yeah, this was the XML file for configuring the EEPROM on the FT2232, because I had to configure the two halves of it to be in the right modes. Yeah, and then RPi to Pluto is the adapter between, so Pluto is the name of the FPGA board. That was the name of the original product. It was from the FPGA for Fun folks. And it's like an Altera ACEX 1K chip. It has the serial port. One of the weird things about the Pluto board is that it has this kind of weird little digital logic circuit such that you can communicate to it through the same serial port that you use to program it. It has this encoding where you send different lengths of pulses that you can encode as different characters at 115 kilobaud. And then those different lengths of characters end up turning into like 1s and 0s and clock pulses for the SPI interface that programs the FPGA. Cool, and then here's the little adapter. So yeah, this is the one that, I had some photos of an earlier version of this in yesterday's stream, but this is the version I actually ended up finishing the project with. So I have this little 74 whatever. This is, I think, just like a 2-channel level shifter. Where's the schematic? Oh, here's the schematic. Yeah, that's not even labeled on here. Okay. 242G14. Yeah, this is like some kind of tiny logic series where they just have like a couple of gates in a 6-pin package. So yeah, I think this is just like an inverter. I don't even know if it's designed as a level shifter, but this logic family is also great at level shifting. So I think that's what I was doing there. I didn't even orient these schematic symbols right. I was in such a rush with the design on this. Yeah, I think the deal here was that the Raspberry Pi, of course, is 3.3 volts, and I think this Pluto board was actually designed for like full strength RS-232 with like plus and minus 15 volts, and it didn't actually work at 3.3 volts, so I had to... Oh wait, was it that or was it the inversion? Maybe that was it. I forget whether the voltage level was actually a problem, but the levels are inverted between like TTL style serial and RS-232 style serial, so I had to invert it. I think that's mainly what was going on here. There's also this pull down, I guess, so that this doesn't float. That's all there was to that. A little thing that just plugs into the Raspberry Pi. So yeah, and then we have this thread, back to the software. So after we set this thing up, we spawn a new thread, and the thread just runs a loop submitting buffers for as many buffers as we have. Is this running a loop? Oh, that's what we're doing. So yeah, we just loop through each buffer slot, and we're just sending them in the same order, kind of round-robin style. So we know that as soon as we've gone through all the slots, we can go back to the first one and wait for it to complete, and then send out a new version of that buffer, and then reuse the next buffer. So we're just recycling the buffers in order. And then each buffer gets filled with a waveform computed by this code here. So it's just assembling all the bits. You know, it's kind of doing the thing where you like rotate the bits 90 degrees. So instead of having all the bits for one sample and then all the bits for the next sample and so on, we have one bit for a sample, one bit for the next sample, one bit for the next sample. And then we're submitting that through libftdi, which is a pretty thin wrapper on top of libusb, which is a pretty thin wrapper around whatever user space USB access the current operating system has. So this ends up turning pretty quickly into like proc bus USB or like sysbus USB access. Yeah, so that's the multi-DAC, and then the mixer is the level right above that. Dumb crossbar mixer. Yeah, I was in a hurry when I wrote this. Tracks. Loading. Oh yeah, I didn't implement a real wave file loader. It just assumes the waves are in the right format. Because what was I going to do, resample them? So yeah, this doesn't, I think, need its own thread. I think it just pulls the audio during the callback that it gets from the multi-DAC thread. So the main thread in this application is running the kind of animation loop. And I think actually the mixer, which is one of the LED components in the FadeCandy C++ library, the mixer will actually spawn a bunch of threads for doing parallel shader calculations. So that's why we're able to use multiple cores in the Raspberry Pi. But that kind of just happens, you know, if you assume that the parallelism is something you kind of just get for free from the library code. It looks mostly single-threaded, but then the audio is running on a totally separate thread. So they would need to communicate if we were doing some kind of audio interactivity like what was planned. But right now I think the audio is just totally independent. It just starts and runs in the background. So we load all the tracks into memory. Yeah, and then we're also loading the JSON configuration. Temporary channel mapping. Oh yeah. Huh. Because the tracks are actually stereo, so I think I was mapping the stereo channels across the 9 channels in a really arbitrary way, just to have a little bit of non-mononess to the sound. But it was very temporary, at least that was my intent. And then I ran out of time. There's the randomization. Oh, it was just a uniform random number generator. I thought I was doing some Perlin noise thing for here, but no, just uniform random. Yeah, the tracks all have to be the same length. And then this is the actual mixer. We're just summing together the samples from all the active tracks for each channel, and then finishing that frame. Yeah. Did I even check the header to see if the format is right? I don't think I did. Oh yeah, constant header length. Yeah, not so much. Yeah, so the sound was all really simple here. Where's the main? Main. So yeah, we're loading the layout. Narrator was the top level module that ran through the scenes, and that was also code that was copied from the earlier LED installation that I based most of this on. Yeah, there's the sensor. So there's the compiled FPGA bit stream, there's the serial port on the Raspberry Pi, narrator.useSensor. Did I get as far as even that? Yeah. Oops. Oh yeah, and that just prints it out. That's as far as I got. Yeah. So if we ran this in, well, I unplugged it, but next time we actually run this, I'll run it like on the command line directly rather than through Supervisor D, and we'll see the debug output. Yeah, I think I'm mostly out of stuff to talk about on this stream. Get some daylight tomorrow and lift this thing up and take the crate the rest of the way apart and get some more photography maybe, figure out what to do. Oh gosh. I don't have good lifting supplies for this. The steel cable they used at the gallery was much better. This rope is already stretched a little bit and it's lower than I wanted it to be. Alright, well, I think that's going to be it for this stream. I should get a snack and try to save some energy to do this again tomorrow. Well, yep. Yeah, I agree with the sentiment from Twitch chat that software is kind of a miracle that anything works. It's kind of how I feel after seeing the sausage made for this long. But yeah, I think that's about right. Well, thanks again to everyone who supports the channel. I couldn't do it without all of you. I still feel like the Patreon is something that I'm both really grateful for and super nervous about, because I feel like I don't know how to rely on, I don't know how to like get good information about whether I'm doing the right thing or not. How well is this working? So it's really nerve-wracking. And of course, Patreon themselves are always like pulling the levers and changing things, and they've got some new changes that are maybe not going to affect me, but I'm sure they're going to change stuff that, I just don't rely on. I can't really trust them, right? So I don't know. Where am I going with this? I'm rambling. But I appreciate all my patrons. I also want to know how I can keep them happy. I also want to be able to do other things that are not as reliant on Patreon. So I'm going to try to see if I can do things that maybe are a little bit more direct to contribute something back to all of you, whether that's like making stuff available for sale, whether that's just having some kind of like direct donation platform that can support the videos. I don't know, but anyway, I'm gonna stop rambling, but I hope I can keep making things that some of you find inspiring, because I certainly appreciate being given this opportunity by all of you. And so thank you, and thanks for all the work that you do to spread the word when there's something you're excited about, and you tell your friends. That helps a lot too. Anyway, I'll sign off for tonight, and should be back here tomorrow with some more of this, maybe with some more prep and lifting supplies. Alright, see you all next time. Happy hacking.